Start with the electrical part. Required parts. A list of components will be provided in the video description. Tools for assembly will also be needed. Wiring diagram. The diagram is divided into two parts to simplify understanding which components connect together. First, solder the gyroscopes and the encoder, then proceed with the buttons. Preparing the wires. The wire lengths are indicated on the diagram. Strip about 3 mm of insulation from each end. Twist the stripped wire ends so that the strands remain neat, then tin them on both sides. It is recommended to use wires with silicone insulation because they are more flexible and do not interfere with the precise operation of the gyroscopes. Soldering. Place the wires into the PCB holes according to the diagram and solder them. After soldering, always check each wire connection for continuity. Even one poorly soldered joint can disrupt the entire circuit. For the second scrolling gyroscope, use short wires and additionally solder a wire between VCC and AD0 to assign a different address. Check the solder quality and pair the wires by color, red to red, black to black, etc. Then connect them to the main board and inspect each solder joint again. Encoder. Remove two mounting tabs with wire cutters. Shorten the encoder shaft by 5 mm using a Dremel with a cutting disc, because a suitable encoder length could not be found. Apply a small amount of solder to the encoder contacts for better adhesion, then solder wires approximately 8 cm long. Microswitches, buttons. Sometimes microswitch contacts are oxidized, making soldering more difficult. To address this, use liquid low-temperature solder. Apply it to the contact, heat it with the soldering iron, and then the wires will solder easily. Connect the wires as shown in the diagram. Solder the black wire to the first contact of the microswitch. At about 4 to 5 cm along that same black wire, carefully remove a bit of insulation and solder the second contact. The diagram indicates where to do this. This approach reduces the total number of separate wires. Final wiring assembly. Take the black wire, in this example it is gray, and twist together 4 wires. Add another 6 cm wire, wrap it around, and solder. This helps prevent wires from tangling during installation. Slide on heat shrink tubing and heat it with a soldering iron for a snug fit, as fitting 4 wires into a single bored hole can be challenging. With this, the electronics are ready and can be placed into the housing. 3D printing. The parts can be printed on an FDM printer costing around $250, but the quality will be significantly lower compared to a Resin SLA printer that costs about $200, assuming similar printing costs. A Resin printer is superior in terms of both speed and quality at comparable equipment and material prices. However, it has one disadvantage that will be discussed later. A test print will be made to demonstrate the difference. The Resin printer completes the print in about 2 hours, while the FDM printer requires about 4.5 hours. Although FDM settings can be adjusted to improve quality, it will not fundamentally change the outcome. As can be seen, parts produced by the Resin printer look much better. When printing multiple parts, the time difference becomes even more pronounced, about 21 hours on FDM versus about 6 hours on the Resin printer, despite needing to split the process due to a smaller build area. Now about the single drawback. A Resin printer uses liquid resin that requires careful handling. Always wear a mask, goggles and gloves. A large number of wipes will be needed to remove excess resin from the printed part. After cleaning, the part must be cured under a UV lamp for about 30 seconds to fully harden. Occasionally, errors may occur. For example, a poorly calibrated build platform can cause layers to detach, and an improperly tightened screw can result in part instability during printing. Such issues do happen, but are easy to correct. For those who have not yet purchased a printer, it is recommended to consider the official Anycubic store. Both FDM and Resin printers can be found there at prices more advantageous than other sellers. For instance, on Amazon the same model costs $329, while the official store sells it for $199, and there is a promo code for an additional $20 off to be provided in the video description. Bought myself 2 printers at a low price. This is a really good deal. Another advantage of Resin printers is the ease of repairing damaged parts. If a part is damaged, a small amount of resin can be applied to the damaged area and then cured under the UV lamp for 30 seconds. Once cured, the part can be sanded. To restore a smooth surface, apply a thin layer of resin with a finger to the sanded areas. The resin will spread evenly, creating a uniform layer. After this, cure the part again under the lamp for 30 seconds. The part is then restored. Next step, painting. Matte black spray paint was used, giving the surface a cleaner and more professional appearance. Moving on to assembly, install the microcontroller. Mount the encoder, ensuring it fits securely into its housing. Install the micro switches, taking care not to damage any wires. Laying the wires so they don't stick out. Assemble the platform for the cursor and carefully place the rubber bands into their designated grooves. Install the middle button, making sure it is fully seated. Also, route the wires into the provided channels so that they do not interfere with cursor movement. The platform should move freely. Stretch the rubber bands. Attach the gyroscope with a rubber-based adhesive to prevent unnecessary vibrations. Secure the wires so their influence on control is minimized. Snap the cover firmly into place until a distinct click is heard. Installing the scrolling gyroscope, apply a small amount of resin into the recess and insert the white handle, then cure it under the UV lamp for about 20 seconds. Next, stretch a couple of rubber bands in a crisscross pattern to ensure a secure fit, and then install the gyroscope itself. Check the fit of the cover to ensure the joystick is not tilted. Tilting can occur due to uneven tension in the rubber bands. After extensive testing, certain rubber bands have been selected as optimal, though not perfect. In this scenario, the center is slightly shifted to the left. To correct this, gently lift one edge of the cover with a fingernail and use another fingernail to slightly spread the housing, applying minimal force. To eliminate the offset, 2 additional spacers can be installed on the opposite side of the shift. After this adjustment, the position becomes properly aligned, allowing the assembly to continue. Installing 2 magnets to secure a part. Attach the first magnet to the support base. Apply glue to the second magnet and fix it inside the housing. Repeat the process for the other magnet. Wait about 20 minutes for the glue to set before continuing with assembly. Programming the microcontroller. Install the Arduino IDE. A download link will be in the video description. Load the program code into the main window by copying and pasting it. Install two libraries. Click the Library Manager icon and search for MPU6050. After installation, search for HID-project. The exact names will be provided in the video description. Connect the board to the computer. Select Arduino Pro Micro or Leonardo, they are essentially the same, from the board menu. Select the correct COM port, click Upload and wait until the process completes. For those who purchased the kit, the microcontroller comes pre-programmed. Simply connect the device for immediate testing. Testing the device. Connect the device to the computer and ensure that two LEDs light up. This indicates proper operation. Test the cursor movement. Once proper function is confirmed, fully assemble the housing. Attach the molding on top of the cover. After the adhesive sets, flip the cover over and install the buttons. Installing the buttons. Ensure that the buttons are oriented correctly so that they do not contact the rubber bands. The upper buttons should be installed with the cutout facing to the right. With the cover turned upside down, join the two halves of the housing. After connecting them, gently flip the device upright for final assembly. Assembling the handrest. Select the preferred type of mounting, rigid or spring-loaded. These can be replaced later if needed. For a spring-loaded mount, insert the spring into the designated hole and press it in. Position the handrest so that the springs align with their designated spots, then compress the assembly. Fit the mount into the slot and lock the handrest into a comfortable position. A non-spring mount is installed in a similar manner. Install the chosen handle and press it in place. 4 handles are included, allowing selection of the most comfortable one. Assembly is now complete. Thank you for watching.